Okay, hello, good morning. Um, yeah, I haven't streamed for a while. It's been a few days off here in Norway. It's been like the kind of Independence Day um, in Norway. Yeah, and just haven't had a chance to do any streaming. Also been like reflecting on AI and stuff. Still not 100% sure where to take the explorations next. But we'll see. No matter, I had some other reflections because I built this. Let's see. Let's move into where is it? Yeah. So I created this. Um, so I had this journey of state machines a while back, um, and also state charts. And there are some core concepts there that makes a lot of sense to me. And I actually made this video on it, where I kind of introduced the library. And at that time, it was very, very simple. It just had the core concepts. And then, as often happens with me, is that I want to make it more accessible. And then I start like building and building and building to a point where it just becomes uh, something that has a higher threshold to learn because it has a more, like the API is just more, I don't know what to call it. I kind of just break the thing, doing iterations, trying. Like I have the best intentions of making it more accessible, but like the core concepts, it's just gone, and code becomes more complicated, like internally, and this is something I gotten better at through time. It's like stick to some core concepts and let other people build abstractions on top of it. Um, so kind of my libraries or tools that I publish, they become smaller and smaller, which is a good thing. But anyway, so I made this video, and it's gotten quite a few views actually, because it was intended as an educational type of video, and regardless of like these tools, it explains core concepts in state management that I think is important to know and reflect on. Um, and a lot of people told me that even though they don't use like React states, they took something from the video, especially the explicit states part, and they use that in their code now. Like it just makes so much sense. But then I don't know what happened. I think it was suddenly the video popped up on my feed, or someone mentioned it to me or something. I watched it again, and then it turned out I had a lot of subconscious thinking on this, because we did use like the initial version of React States at Code Sandbox when we built a new client. But also there we met some friction. I'll talk more about that. But we used it extensively, and we learned a lot, and we made some internal iterations. So we had like an internal version of React States, and the same thing kind of happened. We just built and built and built on top of it, because we met these different cases that didn't quite work out, and then there was some typing challenges and so on. But after all those experiences, and also TypeScript becoming better, I think this is really the React states I wanted to build. So one of the big changes, though, from the educational content is that I introduced this concept of like you have these transitions defined in your reducer. It manages the state predictably. That's great. But what if you want to do something? You want to do some data fetching or whatever. The way I describe it in the video is that you use an effect for that. Like you look at how the states change, like what did you transition into, and then you perform the effect. And that's not necessarily bad. I'm not saying you should never do that. But what happens is that you get this indirection. So you want to understand how something works in the app as a new developer, and you go into the reducer file, because that's what happened at Code Sandbox. These reducers got quite big, so we had separate files for them, and you kind of read all the transitions there, and they make sense. But then you don't know what happens after the transition. You don't know what like effects are executed based on those transitions. So then you would have to move into a different file, and then you would have to read, like, you have the reducer at the top of the component. We're actually going to look at this because we're going to try to refactor something in Code Sandbox just to get a feel for this. But yeah, then you would have to read like all these transition effects, and then there's so much parsing, and on top of that parsing, it's like connecting the dots, and it was very difficult to follow the actual flow of change in the app. So that was just but that doesn't mean you never want to do an effect. Like, you might want to start like a subscription when you hit a certain state, for example, or you want to keep that subscription running in certain states. Like, an effect is great for that. But when it comes to like when I dispatch this action, given that the action is valid, I want to do this data fetching. That's like super tricky to follow. So the way this is solved is that it uses something called commands, and this is not new. Like, you have this in Elm, and I believe there is a very similar library to this that was built by David K. Piano, the Xstate guy. That was also an inspiration for all of my own learnings about this, where you actually don't only return state from the reducer, you can also return like a tuple. A tuple being in JavaScript just an array with two values, where the first value is the state and the second value is a description of something you want to execute, so like a command. And then what happens is this. So the library is still built on these internal concepts. Like, it's only like 50 lines of code or something. It's super, super simple, and it does have the exact same functions as I describe inside this video. It even has like exec and transform and transition. Like, those are the three functions. And they're like one-liner functions, many of them, like two of them. But what happens now is that you can now say create transitions. So this is kind of like how it's trying to be similar to like create context. Like, this is a common name in the world of React, is pointing to create context. So you say create transitions, where you define your state type, your action type, and your command type. And you can define this outside of the components. You should define this outside of the components. It's basically kind of defining a hook. And because it returns a hook. So you just say create transitions, you pass in the state, action, and commands, and now you describe your transitions. So in the not loaded state, we'll handle the fetch action. It will lead to a loading state, and we want to run the command fetch data. When we're loading, we'll handle the fetch success action, the fetch error action, which will lead to these state transitions, and no commands are executed in this case. What also I explored is that instead of having this transform, which is very, very, very generic, I'm not saying this is less generic, but I'm calling it match to kind of conceptually, because it's like a switch statement. That's just way less verbose. And match is something you have in other libraries, like a pattern matching, right? That's kind of what this is. So you can transform the state into values and UI. And the default way of doing this is doing an exhaustive match. By the way, I think maybe there's something missing in this example. Like it doesn't show the actual usage of the hook. Anyways, I'll fix that. But here you can see that. So we're using the data hook. Oh, and I'm also missing the initial state. Anyways, I'll fix these examples. But what you do when you use the actual hook is that you pass in how to perform these commands. So in this case, we show how to perform fetch data, and it's just like a silly promise resolve, and then we use the dispatcher to pass in a new action. Now, the really great thing about this is that this is completely pure. So you can use, you can import this hook into like a test, and then you can just run it in the test, and then you can you basically have mocking out of the box. So you have the mocks right here. So like like I can't even remember the previous version of this. Like after all these iterations, like it had like a dev tool, and it had like testing tools, and like it just got way out of hand. But anyways, when you run the match on this data, you now have an exhaustive match. So in terms of TypeScript, you have to define all the states and what to display in each state. But then, as we explored in Code Sandbox, very often there were only 1 or 2 states that we really cared about. And then the other ones had like a default value. So what I did there was to create a partial match. And it's the same function. So you call match with, in this case, the data and the state that you want to specifically handle. And then you can give a third argument, which is a callback for all the other states. And all of this is typed. So when you kind of write this out, you write match data, you give the object a loaded, and you have a type error, because having 2 arguments is an exhaustive match. You need to define all the states. But when you add that callback, suddenly the typing is fine. Because now all the other states will be in here. So you can still do like dynamically change the value based on these other states. So it just gives a lot of flexibility. But then we also saw like sometimes you're just interested in, at least in Code Sandbox, we had a lot of reducers that basically was just reflecting something async. Like you had to asynchronously load something, but after that, there weren't really other states. It just stayed in the same state. And in that state, with its initialized values, you just wanted to pick these things. You didn't want to like do a match on the different states. You just wanted like a specific value. So with the same match function, you can actually call match with the data again. But then if you use a string, it will, and all of this is typed, you can give it any of the keys, and then if that key exists, it will return the state. So given that it is in a state where that key exists, it will return that state and you can access it. And if not, and this is like optional chaining, is a beautiful thing here. So yeah, so to me, this was kind of a relief, or kind of, okay, this is what I wanted all along. And then we have like a very simple debugger. I can show it to you. So like it's a super, like the idea is super simple. It's like, I even state that, yeah, I don't know how many lines of code it is. Like conceptually, it's very powerful. Everybody should know about these concepts. And then the tools needed to actually express these concepts requires very little code. And then what I've been able to do here now is to create what I think is the exact level of abstraction needed to like really take advantage of this. And also solving the indirection issue using commands instead of having only these transition effects. So yeah, So let's see. Let's go into Code Sandbox here. Let's see if I can zoom in. Oh, it's how do I zoom? Zoom? No. How do I zoom? View? Zoom in. There we go. Wow, there's a lot of terminals there. Let's see. There we go. Maybe I can zoom in even more. View, zoom in. Yeah, we don't really need to run the server or anything like that. We just want to go in and, well, we need to install the package. Let's do that. Code Sandbox v2 pm and React state latest. And hopefully this works. Like this is an old package, and you know the ESM CommonJS problems. I'm not sure if I resolved that here. But we'll see. Okay, cool. Oh, do we start it after installing dependencies? So we're gonna find. Oh, where are you starting the dev server? I think we do that after installing dependencies. Oh, in use, weird. Let's see. So we call it features, and maybe we can look at, so for example, here we have a branch. Maybe this is a good one. So here you can see what I mean by the indirection. We have a reducer, so it has these states, and we also have like public and private action. Yeah, this is also something we played around with, which is hassle. But here we have like the transitions happening, and that's really fine. So we have like forking branch, creating draft branch, creating branch. I think this is fine. But what happens now is that when I go in here, this is where I figure out, oh, okay, so when we're creating a branch, when we go into that state, this is what's going to happen. If I go into forking branch, this is what's going to happen. When I go into creating draft branch, this is what's going to happen. And then we have, okay, if I go from creating branch, I call this action and move into ready, or I do this and this and this, then we're going to do this. And like, it's just really hard to reason about the flows, right? You don't get like a single view of how it works, which is a big problem. So maybe we could try to refactor this one. And this API event here is actually related to, we had this concept of, also with the best intentions, this concept of an environment interface. So we would kind of call this, you can see it here, we would kind of call these, we would just call API create branch. There's no promise here, right? Because React doesn't manage promises. Well, there are new patterns now for handling it better. And now with React 19, you have like the use hook and everything. So that's also changed now. But at the time, we created this flow where, okay, so if we want to create a branch, we're just going to fire off that thing. And then as you can see here, we are subscribing to events from the API, and we dispatch those into the reducer. So basically what happens is we just call this, something happens, it will emit some events. And then these events are handled here, like API create branch success. Like it makes a lot of sense, I think. As I said, like React is a subscription. The components are subscription based. It's not like promise. It doesn't really support promises. So doing this and also making these events part of the transitions, so they are only handled in the correct states, is also very, very appealing. That said, it doesn't need to be that like convoluted. So what we're gonna do is, let's see. What we're gonna do is, yeah, refactor some of this. Yeah, and what I meant to say is like that's why they're like private, because they shouldn't really be dispatched from actual application. This is something that happens inside this like branch hook or branch feature. But maybe we could drop that. Because what's interesting now is that these things, they become commands instead. So they are like already private. So we're gonna, yeah, so we're just gonna play with this. We're not gonna actually make it executable. We're just gonna look at how will the code look like. So what we would do here is do, I get the use branch or use branch transitions is create transition. Is it here? No, transitions. Huh, interesting. And then we need, so we do still need type command. We'll see what they're gonna be named. Let's just call it never for now. Oops. Create transitions from React states. Okay, so now it starts complaining, and I think we should be able to just move this over. The only thing we need to change is like adding the call for the commands, basically. So one thing here is now I'm sending in the action first, because that's another thing. Is like when you handle a transition, it's based on an action. So it's very likely that you want access to data from the action first, and then optionally you might want to look at the current state of the application to figure out what to do. So now the action is the first param. And then we can do this. What I like about these commands is that they feel imperative. Like we have this kind of declarative abstraction of like making the code more predictable, so that you can't just like imperative code by in of itself is very unpredictable, in the sense that if you tie a method to some UI or something, it's very likely that that method will run when it's not supposed to run, or you didn't intend it to run, especially if it does something async. So what this transitions layer does, it just makes, it kind of puts the imperative code behind this layer of ensuring that, yes, indeed, it's safe to run this imperative code now. That's what it is. It's a safety layer. And you might think that this is completely overkill, and you might be right about that. This is very like, this is coming from a very theoretical place. Like I know there are bugs that happens because you don't have this this layer that makes it 100% predictable. But you can argue like the overhead of having this layer understanding it, getting into that mindset versus like just fixing those bugs that like very rarely happens. I don't know. I can't answer that. But that doesn't mean we shouldn't learn and reflect and yeah. So what's also great here now is that we are actually getting proper typings here. There was an initial problem here because these return types here, they weren't constants. So you had to like introduce like as const here, for example. It was like very tricky to make it good, but I still think, yeah. So there is still a problem here. And that is, so if I don't have the workspace ID, it gives an error. But if I add something to it, it doesn't give an error. And this is because TypeScript doesn't have exact return types, which bothers the hell out of me. I was part of that discussion. Maybe we can take a look at and see exact return types, TypeScript. Yeah. No idea where this conversation is now. Like it's a, I think I was, did I say something here? Oh, maybe this is another one. Shallow exact. Is this something? This is a problem for exact types. Yeah, this syntax change will be a new feature. Yeah, exactly. A lot of people want this. Build on map types. What the hell is this? Yeah, so Flow actually has exact. But yeah, I wonder. I'll try to summarize the. Summary. Our hopeful diagnosis is that this is a XY problems wherever possible. We should use. Yeah. Three weeks ago. That's interesting. You can. I haven't tested it extensively, but it seems to work well. Yeah, shallow exact. But is this? Yeah, validating function parameter. Yeah, first class language feature. Yeah, exactly. Yeah, so this doesn't work and is very, very annoying. It's exceptionally annoying. Where's my VS Code? No, where was it? Oh, we were here. This is exceptionally annoying. Because what happens is that when I implement this the first time, it's fine, right? But what if I change the type? I'm not able to go in and like remove these properties that aren't valid anymore, and you just don't know. It's a really bad problem to have, I think. So there is a way to get around it. So I did introduce, like, you can call like transition, like you can call it like a function, Because if it's a function param, then it works. It's awful, but it's but yeah, those can be exact, but return types can't. So if you had like access to this transition, maybe it could be like here, you would have like transition here. You could do it reliably, and maybe you should, because this is a real problem. You know what? It will also remove the tuple thing. Yeah, maybe we should check that. But now we're about to get into like, oh, let's add that. Let's add this. Let's add that. But what I like about it, we don't need a tuple. You can just do transition, and then you can give it 1 or 2 arguments. Okay, at least we're gonna try it. Okay, we're gonna try it. Let's see. React states. I'm just gonna run this locally. Do I actually have React states here? Development. Do I have React states here? No. Let's see. Git clone. I think it's yarn. Let's see. I'm gonna make this much bigger. Like that. And then we're gonna, what the hell? Didn't I remove these excalidraws? Okay, so we're gonna try, as you can see here, like this is actually all the code, and most of the code here is like, it's this debugger and it's typing. Like the gist of it is typing. So maybe we can look at the actual output. Yeah, so it's like less than 100 lines of code, where most of like all of this stuff is just for the debugger. Yeah, like it's very easy to read through the code. Anyways, what we're gonna do is are we gonna call it transition? Let's just do that for now. Let's see. So it's this thing that we call create. Where are you? Create transitions. And what we're gonna do is we're gonna need to make transitions a callback instead. That's gonna return the transitions, and then we're gonna have transition, and this is gonna take let's see, it's gonna take, you need to pass in the state, that's important. So we're gonna give it state, always need to pass that, and then optionally you can pass a command, but it's gonna return this thing like so. And then we're just gonna go in here, maybe we can actually define it up here. Const transition equals state command, and then if command, we're gonna return state command, and if not, we're just gonna return state and null. Oh, I guess we can just do like this is all it's gonna do. This is only for typing. And then, oh, yeah, transition isn't really the best name here. Yeah, because this isn't really like the transition. What should we call this? What should we call this? Like it's more of a result kind of thing. I'm just gonna call it result here, and then we're just to test it. So what we need to do here is I guess we're just gonna call it with result. T transitions. Oh, this is just because of the if I do this, can I do this? Oh, I think I need to do like as. Yeah. Anyways, so we can do a yarn dev on this, and then we can look at the demo app. So now we have this transition. So we should be able to say transition state. Oh, are you angry with me? What did I do? Oh, sorry. This is bad. It doesn't actually return. Sorry, this is wrong. Yeah, we just have to. Sorry. There we go. Yeah, so now we do this transition instead. So if we say transition, cool. Because what happens now is if I add foo here, you see it gives an error. And that's what we want. We have to make that work, and I don't see any less intrusive way of doing this than this. I wish there was a better way. I wish we could just express with normal. Yeah, I wish we could express it with just normal JavaScript, but we really can't. And it didn't look like they wanted to implement exact return type anyways. What's nice though is that you could argue that having that array would kind of make it is also a thing. Like tuples isn't really a thing in JavaScript. So it's like a term that you kind of have to learn, and it might look weird to people. But yeah, I think this is fine. I think we're gonna do this. Like this is better than not having it. So let's just do. And this is kind of a new feature, I guess. Well, it is a breaking change. But I just released this package. This is what I do. I don't quite follow somewhere. I should, but I don't. Let's see, git status. Let's add this, I guess. Yeah. Are we on? Yeah, git commit and transition for type safety. Yeah, because that was a big one. Very annoying. I think actually, I'm not sure if we even fixed that ever. So yeah, this is what I mean. It's like I'm taking all these like quirkinesses that I found trying to implement this and just fixing it, at least what I consider now to be the best possible way. Did I push it? Yeah, npm publish. Let's see. Oh, let's see. Sorry, I need my phone to. You have to excuse me. Let's see, Orphe 297 383. Boop. Oh, 3. Oh. Oh my god. And we are back. I'll close this. It's published. We're gonna. Oh shit! I forgot to update the docs. Isn't that typical? I forgot to update the docs. But we had some other errors in the docs as well. So let's just fix that immediately. So this would be transition. I'm gonna do this. Transition, and then we're gonna say transition. Cool. But we had some other thing. Yeah, we had some wrong. So use data actually needs to pass in the initial state. I forgot about that. Didn't I have something else as well? Was it only that? Cool. And I really liked how I did the debugging. Like I've always, like, how do you activate the debugger? And you can do like process end node end internally in the library, but it's not reliable because of ESM. There you have a different check. I have no idea how React does this. But what about just exposing this? You choose how to make it active. And then you can also implement like local storage. You can implement like a shortcut to make it like change its active state. Like it seems like a way better interface to activate debugging tools. Anyways, I digress. There was something else that I did that wasn't that great. I can't remember. All right. Whatever. Okay, so we're gonna release that as, I'm gonna release it as an actual update, because then we have the same information on npm as well. So I need my phone again, sorry about that. Mm, 309.10.35. There we go. Nice. Okay, so we're gonna jump back into it. And of course, we'll need to update to the very latest version. Would that be 8.1.1? Let's see. Sometimes it takes a little bit of time before the actual package is out. Oh, yeah, why isn't it showing me? Let's try again. Oh, come on. Which version are we running? Oh, there. Did we have it? No. Ah, come on. Where is the... Oh. Modules, React states. Oh, interesting. What's this? It's Simlink. Oh, let's just install a specific version. What was it? 1.1? And let's restart the language server again. This is weird, right? Why aren't we getting a type error? It isn't the latest version. How do I... weird. React states. Wait, what the hell? Oh, fuck, I forgot to build it. I've done that before as well. Yarn build. I've done this so many times. Oops. Forgot not to build. I'm so not a very organized person. And again, 831.837. Let's see. Okay, let's try again. Let's see. There we go. Transition. Yeah, I should probably explain why we have that transition function as well in the docs. So now when we put that, boom, now it's wrong. Great. So that's what we're gonna do. We're gonna add this transition in front of everything. And then we're gonna take a look at what we're gonna do with the rest of the things. Let's see, transition. Maybe we'll even find a bug. Transition. Okay, it reads kind of nice though with prettier. You kind of have dives in and then it does the actual transition. I like that. Okay. What were we doing? Yeah, we're just going through this. So when we try to create a contribution, like this is how you see how we kind of protect it. It's like, okay, when you create a branch, you move into creating branch, and then you can't create another branch while it's doing that. You can't create a contribution branch. You can't create a fork or draft branch. Like this, it just protects it, right? So that we don't mess it up in the UI or the user. Or the user double clicks something, or like this stuff happens. Okay, transition. And then when we're creating, so this is the interesting part. So when we are creating a branch, we want to actually command it to, command create branch. And I'm not quite sure what it needs. Let's just see if we can do this. Maybe are we able to? Oh, what the hell happened to my video feed? There we are. Sorry about that. So how do we actually perform these create branch? Yeah. So let's just take the first one. So when we create a branch, we're also gonna send, and that's also interesting because previously what these commands clean up is that previously, like creating branch would need to have all this information, but now it doesn't need that anymore. It just needs to say that I'm creating a branch, because it's the command that actually takes this stuff. That's so you would only expose what's actually needed by the UI. And then you have create branch. Oh, new branch name. I guess like this. So you would rather do this. And this is the point, right? Now you see it. So when it's in a ready state, which I think is really, yeah, its initial state. We kind of use ready as like a generic state. But anyways, when it's ready and we get a create branch, we'll transition into creating branch, and we're gonna call the command create branch with this information, because we don't really, maybe new branch name is something that we would like to have in this state, but I don't think we use it for anything. And then let's see what it does with creating draft branch. There it only needs source branch name. Yeah, so we're gonna have, let's see, create branch. Create draft branch, and then it only needs this. Did it actually? Yeah. Can optionally send a source branch name for whatever reason. Command create draft branch and then source. Yeah, this is interesting. Oh, that was contribution branch. Yeah, I guess that's like the, it is very interesting. How does these things, so all of them actually calls, yeah, I can't remember all this business logic. Like, what's the difference between creating a branch and a draft branch? I would imagine you need all of this. Like, why does it use workspace ID from the state here? Why does it even have workspace ID there? Because it has it out here. Oh. Where does it get workspace ID from? Oh, sorry. Sorry. It gets it from the action, of course. I forgot. We flipped the arguments. So it gets yeah, but then you can say that create branch optionally takes a workspace ID. That's fine. So maybe we can just use create branch here. I have a feeling we can do that. And then we can do like branch name, but that might also be optional, right? And then let's just make this optional as well. So when you want to create a branch, the question is like, oh, now I'm getting into business logic, but like, is this valid? Can all of them be empty? I don't think it really can. But they're all calling the same API, so yeah, it can be undefined. Yeah, I think it's fine. Yeah, I think we're gonna try that. So create branch. Yeah, we can say or 0, fine, to kind of just to the action. Again, I don't want to put too much effort into this. And we just want to see how it actually looks. So this only had creating branch, draft branch. It only had a source branch name. But it didn't even have that, right? So workspace ID is 0. Yeah, like this is kind of, I wouldn't do it like this if I had this API. But the point is, as I said, the point is to look at the actual code. But yeah, maybe that's like enough. As we're seeing now is like how we make it possible to look at these transitions. You see what states and actions are being handled, how it transitions, and what side effect we want to happen related to that. And the only thing that's like bad about this is that it's like completely pure and declarative, which is kind of the good thing as well. But if you want to know how do we actually create that branch, you have to go in here, and then you have where's the actual, oh yeah, we do use reducer. What did I call it? Use branch transitions. So we will kind of have use branch transitions instead. And then we would have create branch. And we would like take this, don't need this. And, oh, wait a minute. Good thing we're testing this. You see this? It changes based on the authorization. But I think that's fine. Like we do pass in the so these commands here, they are like the reference updates whenever this component reconciles. It's interesting. So what you could do, yeah, like you could make it, I guess, a callback and then do the same thing. You have like the authorization is, but then you have to type all of that stuff. So it's just easier to do it like this. Anyways, so you have use, and then you have creating draft branch. That will be the same, right? Yeah, yeah, we would have to kind of, yeah, because it takes a workspace ID here. We pass a workspace ID there. It's because you can choose to branch something into or fork something into a different workspace. So this should really be called like default or current workspace ID or something. Or target workspace ID. And then we would have to like target workspace ID equals or workspace ID. Yeah, but never used. Yeah, we wouldn't have to do this. Anyways, sorry, I'm getting into too much stuff here. Was there anything? Yeah, so one thing that might kind of get out of hand is like you might have a lot of things happening here. Or I guess that's the, like we haven't solved indirection completely. And I do wonder, like I've been exploring many times, is there a different version of this where instead of like doing, let's see, can I go to Excalidraw? So instead of like doing, let's see. So what we're doing now is that we're doing a dispatch, and that dispatch has an action. And then this hits the reducer. Reducer. And then we do a transition. Into state command. Or let's do this. Right? That's what we're doing now. We're controlling this. Like the user just has an intent to do something, which is conceptually makes a lot of sense. They just have an intent. They send this action, it sends it through the transition layer, and out comes new state and possibly a command. So you're kind of running the logic last. So, but when it comes to reading that code, it's not ideal because we have this indirection, right? You can go into the reducer and look at the transitions and see how it transitions from one state to another, what actions are available in the different states. And also now with reduced indirection, you can also see what commands does it want to call related to that action and the state and everything, The problem is that you can't see the actual implementation of that command. Now you have to move to a different file to see that. I'm not sure how big of a problem that is, but it's not straightforward. Like you have to write all these typings, really. You can't just create, like normally if you wanted to do this, like you could just write a function called like create branch. Just do this, right? And then you would just make it happen. And it would have like you wouldn't have any of this. You just have this method and it just runs the logic for actually creating a branch. And that's why it feels like with Redux and everything, you felt like you slowed down. It's because you have to describe all this additional layer of just doing something. But that layer is exactly what makes sure that whenever this method is called, it's actually valid to run that method. And this is what I've been reflecting on. It's like, would there be a way you can actually write this? I remember I wrote this API where like if this state is cool, like you would do these explicit if statements to verify that, okay, it's actually valid to do this now. But that also isn't good. And it doesn't actually have transitions in it. Like there's no way to like, you're just explicitly checking the state. Which is kind of sucky. So I wish there was a way that you could flip it around. Like if you had create branch, you could say, you rather take it from the perspective of like the thing you want to do. And then you describe when should you be able to do that declaratively, and then you have the implementation of doing that thing. Yeah, it's very interesting. And it's also like you have this, and when you actually run the command, you then have to dispatch new actions back into the thing to like say it was a success or an error. Like it becomes very, very verbose. It becomes very descriptive, but it also becomes very verbose. And I don't think developers like to code in that way. I know at least I had like issues with this. I have colleagues who's just like, oh my god, I just love writing imperative code. It makes me feel powerful. It makes me feel like I just write the code that's necessary to make the thing run. And it's true. But you're not writing this code to make the thing run. You're writing this code to make that code like more predictable. Oh shit, I have a low battery on my Mac. That sucks. Anyways, so like how would that look like? So you would do like, you would kind of guard it instead. So you would, maybe you would say like this transition. So you would have like a transition of states. So you would say this dot this when ready or something. Like I'm just, yeah. Or this state is ready. This state when ready. Hello. Um, like, and that's also the thing. You're not like you typically want to do something async, so you will kind of partially describe. Like, there's really no good way to do this, I think, because what happens, like, I'm very in my head now, but what happens is like, yeah, I'm just playing around with. I have this. Um, I did this video a while back, like 3 years ago, about explicit states and um, constraints in state management. And then I created this little library. Like the video is very educational, and I'm showing a little bit of code to actually make that concept like achievable. Um, and it's a good concept. It's a fundamentally good. Yeah, for sure. Just ask questions. But yeah, so but based on that educational content, I built this little library based off of it, and then it just kind of blew up. Not blew up as in getting popular, but I broke it because when I apply those concepts in practice, there were a lot of small challenges, and I kind of built on top of it, and kind of dealing with each thing at a time. And we also use this at the company I work at. And I never got a chance to like sit back and take all those experiences with the initial core idea and kind of rethink it. But I've done that now, and I'm really happy with the result. But now I'm like reflecting on like how we normally do imperative programming and how nice it is. Because if you just want to create a branch, you create a method and you write the logic for creating the branch. The reason you want this like layer of dispatching and transitions and like state machine-ish stuff is that you want to protect creating a branch so that you don't call or you can run that logic when the logic is not supposed to run, which typically happens like somewhere down the line in the UI implementation where the user might like double click something, or you have some complex asynchronous flows where you I don't know, just call something twice, or there's a race condition or whatever. Like, these are the kinds of bugs that's hard to track down. But if you add this layer on top, you'll avoid those situations. The problem is that the layer on top is very verbose. And it's so easy to me to kind of relate to why the hell add that abstraction. Like, it rarely happens, the problem you're describing. Like, the cost of using the tool is more than just fixing these edge cases when they happen, arguably. Anyways, but I was wondering if there's a way to, instead of having like this traditional dispatch of an action into reducer, transitioning, like having this protective behavior of a transition, and then on the outside, and then you have to move to the outside to actually read the implementation of creating the branch. So this is just describing the interaction of wanting to create a branch and what details is needed to create that branch. While the actual branch logic, create branch logic, is somewhere else. Yeah, and then how could you start with a method and protect that method in a different way instead of having like a dispatcher reducer and all of this stuff? Okay. What do you go to when you want a real-time synced state when working cross-stack? For example, a system being Python and front in JS React, so or chosen numbers and function or share. Yeah, real-time synced state. Yeah, so what I've been, I'm trying to think of an example where I've done that. So like in the scenarios, I've been where I wanted that. I've typically been like working on my own little project, or I've been at a startup where you don't want to invest too much in like custom solutions. So I've just been using Firebase for that. It's exceptionally simple to use, and it also has all these other features that you typically want when you want to build something that uses like real-time synced state. I actually have a video. Maybe I can find it. I found this. I found this video. Let's see. Let's see. Where is it? Christian Alphone Ducky. You might find that. Yeah. Wait. Planning? No, not planning. Yeah. A real project. This one. So this is a really interesting. Yeah. So this is like how many years ago? 7 years ago. But I suddenly watched this video, and I can't remember why, but it was fun. Like it was a fun looking back. But I think it's a good presentation on architecture of dealing with like real time in a startup. You don't have a bunch of senior engineers. How do you develop components and all of this stuff? But I do talk about real time there. Yeah, like yeah. So the interesting thing about like one thing is real time in the sense that like what do you actually want to sync? But so for example, Firebase is like a, how should I put this? So you don't think about you don't really think, you don't kind of replicate the database on the client. You still kind of fetch the data from the Firebase database in the backend, and then you create subscriptions. So it's unlike other solutions I've seen where you literally like make database calls in the client. And it's almost like the API. It feels like you have the database on the client, right? But it just syncs with the backend. I guess Meteor was kind of the first like web framework that kind of did that thing. I haven't really used that kind of solution, but it's an interesting concept. I've also seen presentations where people do like local databases, even just using like CRDTs and stuff to make things collaborative, which they sync with the backend. So that is also really interesting, but I don't have like first-hand experience with that. But what's interesting is, like you mentioned, function triggers. So in this video, at least, I explain how we do, what did we call it? What did we call it? Tasks? Did we call it tasks? Yeah, I think so. So in this Ducky project, what we would do for like function triggers is that we would allow the client to send tasks into Firebase. And then there's a service running that looks at these tasks, picks them up just like a queue, and then performs whatever on them. And then maybe updates the database or calls some third-party API or whatever. But that's a really cool concept. I think it's changed now in Firebase how you would do that, because now you have like first-class functions and stuff in Firebase. But yeah, it's interesting. With hooking a front end to the DB is how to keep the DB safe if people change. Yeah. So yeah, want to keep it safe. Yeah, I guess there's like different levels to that. I would really look at Firebase. Like if you have a project and it's not completely obvious what kind of features you need, but you're kind of onto it. Like I want some real-time behavior. I definitely need a database. I might need some execute some code on the server because of safety and like privacy and not allow people to hack stuff. And you might want some authentication. Maybe you need to store some files. Maybe you want analytics. Like all of that stuff is in Firebase, and it's very accessible as a developer to use it. But yeah, it's not open source. But the equivalent to Firebase is oh my god, what's it called? Supabase. Supabase is the open source. They call it the open source Firebase, and it has all the same features, I think. But yeah, the ways I'm not sure how it's done in Supabase. Actually, Supabase. Yeah, the open source Firebase alternative. So in Firebase, you have something called rules. So by default, your database is completely locked down. You can't read or write anything. And then you create these rules based on your authentication, what you get access to. Yeah. Yeah. And that's like, it depends on, I think that makes a lot of sense to like, if you have very high demands on like performance and it needs to scale, and you need like cost management and all of that, it makes a lot of sense to like go lower level and use like specific solutions like yeah, I haven't heard of Zero MQ. I heard of, is it called Rabbit MQ or something? But yeah, Redis and sockets and kind of do the stuff manually. But if you're unsure about like how things are gonna turn out, I would do something way simpler. Like just use Firebase to get some proof of concept up and going, just to see that it pans out all the parts that needs to talk to each other. So you spend time like on the actual user experience as opposed to figuring out the architecture behind it. Because at the end of the day, that's like what's going to determine the success of the app. Is like, is it usable for people? Do you have a great user experience? And it's really like, it's very rarely that you have like a highly optimized, cost efficient custom implementation in the backend that gets you there in the first place. Like at some point, maybe that's required to make the product be competitive. But in its inception, that's not why people come to the product. It's not because you're, well, arguably, like generally, I would state. But I know how, I know exactly what it's like sitting there and having this idea and thinking about what tech to use. And you learn so much going lower level, choosing different tools, putting them together. And when you see it working, like it's super seamless and optimized and all of this stuff, it's an amazing feeling. But your users doesn't care. That's the problem. Well, of course they care if it's super, super relevant for the experience. But I guess all we have this term in Norwegian, like I think it's in English as well, like everything at due time or something. No, that doesn't sound like an English expression. It's a Norwegian one. It's like, what's the minimal thing you like? What's important right now, and then do the minimal thing, and then that will change over time. Anyways, I'm getting philosophical. So yeah, but it's funny. Like product development is, I think that's been my biggest struggle as an engineer. I've had all these ideas for products, but I get so quickly discouraged when I start implementing it. Because I'm not really, I don't consider myself like primarily a product developer, because there's so much in product development which isn't about coding and the technology. So what I kind of settled with is like, no, I can do product development, but I can't do it on my own. I have to do that with a team. But on my own, when I have ideas for products, I tell myself this is only to learn. And then I'm free to like go as low level as I want, explore whatever concept that like tickles. And then I'm happy if the end result is that I learned something, instead of feeling bad because I got discouraged and didn't finish the product. Yeah. Anyways, I'm getting super philosophical here. Oh yeah, the great branch thing. So yeah, no matter. So I think you have to be like conscious about the cost of adding a layer like this. Because there is definitely a cost to it. And what I'm curious about now is like, how much did we actually reduce indirection by adding the command here? Yeah, for sure. If you ask me questions, I'll ramble like, and I'll diverge, and yeah. Hope it was helpful or insightful to any extent. Okay, but I think I'm happy with what we did here, and I'm gonna let's see, where did I put the actual? Yeah, and this does definitely help. That is for yeah. I wanted to do this other thing as well. I wanted to try. Well, does that matter? I was thinking about using this for in React 19, but I'm not like there's one thing I'm very curious about in React 19, and that is the compiler. I wonder how efficient it will now be to use contexts. I wonder. Like the thing I'm talking about is like, now if you embrace React to do like shared state management, that being global state management, or you kind of do state around a page or feature using a context, you have this issue that if the state changes within the context, any consuming component of that context will reconcile. Oh, my AI strategy. Okay, let's talk about that. I'm gonna play with React some other time. So, let's see. Do I have? I actually have an Excalibur draw here. Funny you should ask. Let's see. Oh, is it this one? No, this is a different one. Where's the one with all? Oh yeah, I think it's this one. Yes. So I have a lot of videos on this stuff. Okay, I think this kind of represents where I'm at. Okay, so I'm no like super expert in AI. I was exposed to this like everyone else or many other people through. Oh, that's actually, I built that project. It's actually open source. Yeah, let's see. I built this for our company. Firebase. Excalidraw Firebase. It is open source. So the point is you can just you can actually just yeah, here it is. You create a Firebase project, and then in the you add your Firebase config file, and in the Firebase console you add Google as authentication. You log in, and then you check. Yeah, and then there's some Firestore rules that checks the. Do we have it here? Firestore rules. Yeah, so you see here, you see that we allow read and write if request of token email matches code sandbox.io. But you can change that domain. So if you have a company, that has like a Gmail or whatever, you can just take this project, change the Firestore rule, deploy it to whatever. Yeah, I don't like that I love Firebase, but I had so many experiences with it where it's just been such an amazing tool. Anyways, so yeah, so you can use it. I can put the link here, or at least it can be inspirational. Let's see. Where were we? Yeah, AI. Yeah, so like most other people, I was exposed to AI through ChatGPT when they launched the assistant. And I'm no like super expert, but I've had like a couple of months, I guess, where I've like done some deep research to try to understand it better. And I've been very like, when I see new tools, I try to take on very ambitious ideas to learn. It's not because I necessarily want to. As I said, I am not like a product developer in the sense that I can like take on a product on my own. But I like to think of products when I try to learn tools and technology, because at the end of the day, that's what you want to apply it to. So I was thinking about like this, like everyone else, like this coding assistant thing. And then as I started learning about these LLMs, I realized that they aren't as human-like as you might think when you interact with ChatGPT. Like there's an illusion with ChatGPT, and that is that they have this human interaction, which is I ask you a question and you respond to me. That's a very human type of interaction, as opposed to calling a function and getting a JSON response. That's a very like computer type of interaction. And as I learn more, it's like these LLMs, as their base model, they only complete documents. Like they don't even answer questions. Like if you ask it a question, it doesn't really like it just completes whatever you write to it. But then OpenAI, like at some level of abstraction, like did fine tuning for conversation, so that it would have this very human behavior of like, ask me a question, I'll answer you, and we're going to have a conversation about something, as opposed to trying to complete a document from the internet. And then what they did is that they did add like, but it's still just text, right? But even just doing text, it's very much like a very creative type of tool, while you might want it to be much more reasoning and planning focused. So what I mean is like, these language models are great at generating like articles and stories and jokes and all of this stuff. But when it comes to like actually reason about something and do complex planning, they can't really do that as of now. Like things are happening fast. So it's kind of like our brain. our brain is like a system 1, system 2 brain, where system 1 is based on just quick, like it's very little compute and energy used by our brains normally. Like we're defaulting to system 1 where we use our intuition. It's like fast compute, little energy kind of thing. But when we actually need to do reasoning and planning, we trigger our like system 2 part of our brain, which requires a lot more energy, takes a lot more time, a lot more compute to reason about something, and especially do planning. And these LLMs doesn't really have this. It's like they're very reactive intuition, just spits out stuff as of now. And then as I was trying to like apply this to some kind of tool where someone who didn't know how to code could just prompt it and it will like actually generate something, I've been kind of moving in this world of like, can you really make the current behavior of an LLM that we are shown from OpenAI, which is this very conversational thing, and use that concept to allow a person who doesn't know how to code to actually get something running? Or do you need to apply other abstractions on top of that to make that work? And that's why we have these things like agentic workflows and all of this stuff to kind of make that happen. So I made this like proof of concept. Do I have it here still? Oh yeah. So I started this proof of concept with just a single assistant, which had a bunch of function calls it could do. Some of those function calls was like RAG, where it would like go and grab information about the existing code and all of this stuff. But it didn't really work because it was a bad user experience. Having this like long conversation about just building something simple like a task management tool or something like that. You can like single prompt a capable model and get like a task management tool in the other end. But I don't want the experience to be what the LLM suggests is a good solution. I want the user to be able to tell the LLM what should be the solution, which are very different things. Like there's a million ways to build a task management solution as an example, but the user has a very specific task management idea in their head. But humans are really bad at conveying what's in their heads to some other entity, that being another human or to an LLM. So you need some kind of interaction that kind of draws that context that's in the user's head down into the app or whatever, something that the LLM can execute on. Yeah, so that was what I was. That's kind of some like, I guess, higher level thoughts I have about it. And then the question is like, what kind of UI and tools do you use to enable that? And that's only half of the problem. The other problem is like you can have a very, very detailed explanation, but you still have to implement the right thing. But the thing that I like in terms of my strategy, it's been like I've tried to use LLMs as we know them now as this conversationalist thing. And then I moved into agentic workflows. But now I'm doing something very different. I just use LLMs as a function. Like I use them as what they're doing, what they're good at, which is generating text. But I use them as a function. So I don't have this like huge ass abstraction of like agentic flows and prompting roles to the agents and describing their behavior and giving them instructions and giving them functions to do things and all of that stuff. I just have a very simple idea of, okay, there are certain functions in this app that an LLM will handle, and it will give me like JSON back, as if I called a normal function in my application. And then I'm just building up a very concrete flow from that and see where it gets me. And I'm kind of doing it out of spite, because everyone's like going into it's not because I think it's the wrong idea. Like looking at the latest like OpenAI model, it's amazing stuff. And maybe sooner than later they will be able to like do really good reasoning and planning and all of that stuff. But it doesn't matter, like, I think, because there's still the problem of moving what's in the user's head to something that the LLM, like removing ambiguity doesn't have anything to do with the model itself. Like the model can be super, super capable, but if the stuff in the user's head has ambiguity when it hits that model, it's gonna just do something, unless you like prompt it to never move on until it knows absolutely everything. And maybe that's how it's gonna end up. I don't know. Anyways, so yeah, out of spite, I'm just using a very, very like programmatic approach where I've created like this very traditional flow that is helping the user express their idea. And then I'm going to continue trying to just use these LLM functions to not just say try to implement this code, but actually specifically go and figure out, okay, there's one function call that's going to find the file where we should implement this thing. Then there's going to be another function call which is going to figure out what files do we need to generate to implement this thing. Like, just have these very specific function calls, which isn't about roles or anything like that. It's just about there's certain information you need to make a good decision on implementing something. But I'm not saying it's a good idea. It's just a different idea. Anyway, sorry, I saw you made some comments. I just had to run through my... yeah, they're getting better every month. It's amazing. It's so much fun looking at it. Advanced atomic agent framework currently mostly bottleneck by making the... oh, yeah. Yeah, isn't that... like, it's funny how a lot of... I love that, like how backend and DevOps developers and even designers and product developers, like I met a lot of people that like just jump into UI. It's a fun place. Like I think it's nice that people, or especially people in product teams, gets like some intuition about what it means to build UIs, because it's incredibly complicated. Not just figuring out like a good user experience, but actually implementing the state management of UIs is incredibly complicated, depending on the UI, of course. But yeah, magically with a router that you can direct user message to the model agent flow you need. Have unified memory, private personal data stored across all. Yeah, I was playing around with like threads. So what did I do? So I tried different approaches where I would let each agent, so threads, I mean OpenAI, chat completion threads, or not chat complete, assistant threads, I mean. So each agent would have the context of their own thread. So for example, if we were talking about user stories, you would be able to have a conversation about those user stories, and that agent will kind of have those user stories in its context to be able to iterate on it. But I also tried to have like a shared context of the workflow. So in this case, you have like an idea workflow, a planning workflow, an implementation workflow, and debug workflow. Like the workflow had shared context. But now I'm the thing I do when I try to approach problem solving is that I create artificial constraints. So I'm in the mode now where I'm not going to allow to have any shared context. I'm going to see how far can you get with LLMs without having any context outside of just the prompt. As I said, I'm thinking of them as a function call. So whatever context they need to perform the function, it needs to be part of the function call. So like the prompt. Again, I'm not saying that's a good idea at all. It's just interesting. And I'm also using GPT 3.5 as opposed to these more capable models. And that ties into user experience as well, because these other models, they are incredibly sorry, I got a message. What was I talking about? Oh no, now I lost it. What the hell was I talking about? Yeah. So these more capable models, they're like very expensive, and but more importantly, they're insanely slow in terms of interacting with them. One thing is like being able as a user to give a very ambiguous prompt, send it to the cloud or like a background process on your computer, and just let these agents work on it for like multiple, like half a minute to a minute, even hours. That's fine. But it's this reduction of ambiguity. Like, how do you explain what you want the end result to be? And that needs to be a super fast, good experience. And that's challenging. But yeah, they're also, yeah, they're getting better. Anyways, so I have these artificial constraints just to help me be creative, I guess. Go down paths that aren't obvious just because I have the constraints. Anyway, sorry. If you use them as atomic as an agent, management, the most important thing is caching, testing, benchmarking, self-improvement, visibility, and instant. I manage the conversations in Redis, even have branch support. Then you can pick and switch models and have super flexible and personalized session. Yeah, I should really jump to something else. But it's but sorry. Yeah, it's self-improvement. Yeah, it's I guess this is kind of still the open question. Like, and this is why it's so fun exploring this, right? It's that nobody really knows exactly how to use these tools yet. You have like, I just talked to a colleague about Google having this what did they call it? You mentioning caching. Gemini has this new caching thing. So you can give it like a huge ass context and you can cache it. You still have to pay for the tokens, and you even have to pay for the cache every hour. But when you do prompt the model, you don't have to send that huge ass context. But then I worry, like, but if it's like, let's say 100,000 tokens, that context, maybe it's code, like your whole code base, even 1,000,000 tokens, right? It still has to compute from all those tokens. So it would take a long time to respond to that prompt. The way I understand it. So I'm very, again, I'm very curious, like, where do you like put the effort of making these things perform well enough for a good user experience? Is it like adding these like layers on the agents, or is it like maybe you don't have to think, at least for some things you don't have to think agents, maybe it's a more simpler thing you can do. I don't know, but at least it's fun. It's so much fun seeing all these different like YouTube videos, people working on this, figuring out different architectures, perspectives, new technologies, and how close like the research on this is to engineers like us and product developers. It's super super fun. Um, oh, is Grok even free? Oh, I didn't know. I thought you had to pay for it. Well, is it free because you run it locally, or I guess? Uh, yeah. Oh, Grok is just free. Awesome. Yeah, I should try that then. Awesome. Thanks. Yeah, and it's what's interesting as well is like one thing is like this interaction of producing code in this like proof of concept, but in this proof of concept, like I did a horizontal kind of implementation the first time, just had a single like assistant and just did like a horizontal thing just to see if you could actually make changes to a real project and get it into the cloud without knowing how to code, which is kind of insane. But there's so many different possible results that what I did with this proof of concept is that no, I'm locking it down. Like I'm not allowing, like initially the assistant could run terminal commands, it could install dependencies and all of this stuff. But it's just so many possible results that and it doesn't, and the thing about this is that it doesn't matter for a user who doesn't know how to code what dependencies you use and what technology you use. But that's not, that's just like use it, like working on the project locally. And then you have, as you mentioned, like deployment on top of that. You have like database rules you might need. And how do you make the assistant deal with that? So long story short, what I did in this project is that I have an Electron app that lets you open a folder with a project, or sorry, you select a folder and then it will generate a project for you. So it locks down the dependencies it uses. It uses Firebase for, because it just has databases, everything. And Firebase has a CLI tool. So the only thing the user has to do is to download a file. And that's part of the onboarding, is to download that file from the Firebase console and put it into the app. And that allows the app to actually perform tasks on behalf of the user, like updating the database rules and actually push them to the database. It can actually deploy the thing to Firebase hosting and so on and so on. So that's also an interesting thing. It's like the more you can like narrow, I guess that's the thing. Like by default, it's completely open-ended what these LLMs will do. And you have to create some boundaries around them to make them give you the result you want them to give you. The question is like, how do you do that? Yeah, sorry. Yeah, I was gonna mention that. Yeah, I haven't used, like I've used LLMs to generate code for like a web project, but I haven't used them to like iterate on like magic functions, as you call them. What is that concept? Is that like, is that more to is that functions you apply to an actual project that you want to the LLMs to work on, or is it like part of the agentic stuff, like that you make them create functions so that they can perform other tasks? Or yes, exactly, doing function and tool calling with a strict flow with functions you own. Yes, exactly. Yeah, that's what I'm doing. I'm taking as much control as possible, creating as many boundaries as possible, and see what the result is. Is it possible to get something out of that? As opposed to creating these more autonomous abstractions, which I also find super interesting. But I think one of the motivators for me as well is like, what's the minimal LLM abstraction you can use to get some power of LLMs into a product? So a lot of people, when they look at these LLMs, they think about new products. Like, we have to create this new thing. But there's so many existing products out there that could benefit from LLMs. And that's also one of the motivators behind this. I just call it, prompt to JSON. Yes, this is the thing I built. It's super simple, but it's more the conceptual thing. So the idea is that, okay, you have some kind of product, and in some part of that product, it would be nice to get a suggestion on something or whatever. And then you can create these functions, prompt to JSON functions, where you give it a schema, which is a JSON schema that you build up. And then you have a callback for actually sending the generated prompt. And then you can also give some expectations on what it should output. But by default, it will output the JSON from the schema typed and ready for you. And it has some prompt engineering in it to make that happen. But anyways, that's the like the most minimal thing I could think of as an abstraction to start using an LLM, the power of an LLM. And that's what I'm doing now. I'm seeing how far can that tiny little abstraction get me trying to create something more complex. Magic function I call either a call to a model that responds the answer, or usually better generate and cache the code to do thing and call. How do you do like benchmarks? Do you mean like code execution benchmarks? How do you I think one of the things that made me was kind of part of this ambitious thing was that I wanted to create user interfaces. Like, how do you make an LLM validate the implementation of a user interface? And well, like, they can't interact with browsers. They can't actually navigate. Like, they can navigate URLs, but they can't actually navigate as you do in an actual application and track state changes within the applications to verify and all of that stuff. It seems to me like, at least for web development, if you want to create assistants that can create web applications, that's one of the biggest problems. They can't validate their output efficiently. They can validate, like, what I did is that I give it runtime logs. So if running the app after, I could give that back and it will be able to iterate on that and fix it. But it might not start with a runtime error. Maybe the runtime error happens when you click a button. So then you need a user to be in there to help validate it. But for other things, like, you can even ask one LLM to write a test and another LLM to do the implementation, and a third not LLM, but agent or whatever to validate it. And I guess you can do the same for benchmarks, like how performant. But yeah. How about JSON to prompt reverse? Give it example for user input and scribe and desired output. Yeah, it's so funny you should say that. I actually did that. I did this little project because I work at Code Sandbox, and we have in Code Sandbox you can create these browser-based sandboxes. Like if you want to play around with UI, you should use Code Sandbox because it's very like quick, iterative, figuring out and play around with like web frameworks and stuff like that. Anyways, so normally now you need to choose a template, right? What's your starting point? And I wanted to allow you to like use a prompt instead. So you could just say whatever to have a better starting point than like nothing. Like all of these are like hello world. But what if you could prompt it to generate some better starting point for you? And the way I did that is I did what you said. It's like I asked a colleague to go and grab a bunch of sandboxes for me, public sandboxes. I would download them. I would take their out like the files, and I would ask an LLM, what prompt would you use to generate this output, as you said. And then I took that generated prompt and the actual real output that was actually created by a user, some random user somewhere. And then I fine-tuned an OpenAI model on it. The problem though is that it didn't like, so I think I have an escalator on that one as well. Let's see. Where's that one? Is it here? Did I do it here? No, this is more reflections. Where did I put that? Is it here? Yeah. Yeah, so this is my reflections on that one. So what I had in my mind first is like, what if you could go to that dashboard I showed you and do like a counter example with React, for example. And then you would click generate and it would produce the output needed to make that sandbox run. And so I can't quite remember. Yeah, but anyways, that output requires certain files. You might have some npm dependencies related to that, and it's also based on a template. So these browser runtimes, they're based on templates. You have like a React runtime, you have a Vue runtime, you have a Svelte runtime, and so on. So I played around with like doing few shot prompts versus fine tuning, and like the thing is, we have thousands on thousands, like we have millions of these sandboxes. So we have a lot of data we can fine tune on. But the problem is that even though I didn't do, I think I was 100 sandboxes, like the documentation at OpenAI said, you only need between 50 and 100 examples to do fine tuning. But anyway, so with 100, I did not get, I did not get what I wanted. So what happened is that, for example, for React, it would infer correctly what template to use. Because in the JSON schema, I would have like an enum of types of templates. So it would like, fine, it would choose the correct template, but that's not enough. That template requires an index file in the public folder. It requires a package.json file. It requires the entry file that's referenced in the index file. And these needs to be in place for that template to run in the actual sandbox. And with the fine tuning, it would generate, for example, quite reliably the public index file, but it wouldn't generate the package.json file, for example. So it became better, but it didn't become predictable. Another huge ass problem generally with generating code is dependencies. So these models are trained on stale data. So that means whenever it suggests what dependencies to use, if it's not tied to any kind of RAG or some specific context of your application, and then like it will just use potentially old APIs. And in this example, if you were to use Tailwind, for example, Tailwind can be used as an npm dependency, but it can also be used as just an external resource, as a CSS file. How should it understand that? But then, as I think you're pointing to here as well, like I don't need to generate all these files. The only thing I really needed to do is to just generate the code for one component or one file to the base template to morph it to the desired. Yeah, so what I did instead was I would flip it around a little bit. So I would still allow it to, like, you would still prompt it, but it was prompt to generate one single file. And that file, it was just prompt to like generate this component based on this prompt, return a default component from that file. And then instead of doing generate, you would click React, Vue, or Svelte in the app. So I would programmatically handle parts of the experience. So the programmatic part is like, okay, if the user clicks React, I know how to build up the template. And the only thing I get from the LLM is the component that reflects the prompt. And then I knew exactly where to put that component to make it run with the rest of the template. It's interesting. Yeah, to the base template to morph it to the desired app with minimum changes to keep. Yeah, so it's, yeah, it depends on how you want to approach it. That's how I approach it, but it's the same idea, right? Yeah, comments in reverse order. And what happened here is that now the only thing I needed from the LLM was this code, and this worked, right? It doesn't mean that it's spot on with the code itself. Like, it gave a predictable result. It was always a running sandbox. The code itself, like this was also based on GPT 3.5. It would just get better. If you had better models, it would generate better code. Something that was more close to what you had in mind, right? The thing about this experience, though, is that if I use GPT-4, it would just be too slow. Like, if you're on the dashboard and you have the choice to send a prompt or click a template, clicking a template is instant. Like, we're talking like instant. But if you generate a prompt with GPT 3.5, it would take maybe 3 to 5 seconds to do that, which I think, like, more than 3 seconds in that context, that's pushing it even. And with like GPT-4, it would take over 10 seconds to just produce that single piece of code. So you could probably use a different model that's way faster, but it's just an interesting like reflection. But still, I showed it to a colleague and he asked me like, oh, this is really cool. Ask it to do app using Redux. And then we do that. And then when we look at the code, it's using deprecated APIs. So how do you make, and you know, sandboxes, they are about using the latest, like somebody releases a new library, go and try it on Code Sandbox, right? How do you make the LLM able to understand that API? It's not trained on it yet. It can be trained on stale versions of that API. And so how do you actually get it to understand how to use that NPM dependency? And I don't know. how to do that. I have some reflections on how to do it. So one thing I thought was like, as part of the where is it? So as part of this experience, you wouldn't if it deducted. So there's two ways to approach it. Either the prompt deducts what npm dependencies to install, and then you would actually list the npm dependencies, and you would kind of have a first class understanding of these npm dependencies, and you could choose the version you wanted, for example. And we would even be able to go and find documentation for those npm dependencies. That's a problem in and of itself. Like, how do you get documentation for a dependency that the LLM hasn't been trained on? So to bring it into the context. So the closest thing I gotten to that is using the type information. Using the type. Yeah, no worries. I'll just keep talking. What if you use, like, all these npm dependencies have they have typings, or a lot of them has typings. So you can kind of, what do you call it? Deduce, deduct, from the type files, how to use the library. So at least that's what I thought. This, like, the final concept of this would have to be like doing what I'm doing here. And then you would either have to explicitly choose the dependencies you want to play around with, where we download the type files and bring the type files into the context of creating the sandbox. The problem, though, is that it slows down like crazy. So Redux has a shit ton of types. So the context just completely blows up. And if you would like not choose the dependencies beforehand, but you would deduct it from the prompt, you would have to ask the LLM again to produce the code. First to figure out the dependencies, and then again to actually write the code with the relevant API. So I think a final experience would be like, this is where you ask about what you want, what kind of code you want to write, like conceptually, and then you would explicitly choose the dependencies here. And then when you click one of these, it takes this prompt, it brings in documentation from these dependencies, and then it generates the sandbox. Actually, I wonder if I want to play with this, because this is such a, yeah, it depends on what kind of solution you want to make. Like, if you want something to write code in an existing application, you kind of already have a ton of examples of how to use the different dependencies. It still doesn't necessarily have the actual documentation of the APIs, but at least it has a lot of examples of how to use those APIs. But I think that's one of the biggest problems. And you don't want to go to the web and browse. Like, again, it just takes way too much time. Yeah, it's interesting, but I think that's what I want to do next. Like, this is the closest thing I've been to actually producing a product. But the missing part is the npm dependencies. Yeah, should play around with that. Yeah, like, I'm in terms of collab, I'm always like, the heart is there. It's just not, I don't really have the time. That's the problem. Like, I'm working, I have 2 kids. I don't have much time after work. But that doesn't mean, like, I think there's a lot of value in just like reflections and sharing ideas in terms of collaboration. So yeah, I'm super happy to share any thoughts and ideas and so on. So please, yeah, drop me an email, or I'm kind of bad at going on Discord. It's just because I have so many notifications elsewhere in my life. I actually bought a Nokia 3210. I'm going to replace my iPhone with a non-notification phone. because I'm just, yeah, the world has changed. Anyways, I'm gonna drop out and do some actual work. But thanks for joining. This was very. I love getting these questions because it helps me reflect on my own thoughts. So yeah, thanks for that, and I would love to discuss more how to do this or think about these things. But yeah, you really inspired me now to. I think I want to try to find time to work more on this concept because, like, if you can't figure out how to create a sandbox, how the hell are you gonna work on actual applications, right? There's just some very, very fundamental core problems, especially this npm dependency or dependency thing, dependency documentation thing. Anyways, we'll talk later. Bye for now.